A computer, again, receives data as input. The machine then processes it, stores it, and then produces output. And for this reason, the most important component of the computer is the central processing unit, otherwise referred to as CPU. So why don't we watch a video together here that briefly shows how the CPU works together with other components.
The processor is a chip responsible for calculations. It makes all the logical decisions, which are basically all the tasks your computer does, from the simplest thing as open a window, to the most complex, such as completing a 3D animation. For this reason, the processor is known as the brain of the computer. To understand how it works, imagine this scenario. We have a processor, and next to it there is memory RAM, and inputs coming from the output devices, your hard drive, mouse, keyboard, and monitor. The mode of communication between them is called the motherboard. The motherboard is responsible for linking the processor to all the components of your computer. The processor executes three basic functions: receive input data, process this data, and provide output data. But what exactly does all this mean? When you type in some text, for example, each letter entered is input data. The processor receives this data, processes it, and provides the output. In this case, everything that you type will appear immediately on your screen. This all happens in a fraction of a second. There are other types of processors too, which may be installed on your system, but every processor contains several important features. Here are the main ones. The socket. The socket is a type of physical connection between the processor and the motherboard, and it is responsible for transmitting energy to the processor. The core. The cores are responsible for the processing speed. The more cores a processor has, the more functions it can execute simultaneously without overloading your system. The clock. The clock is responsible for defining the frequency that your processor will use to execute one task. It's measured by hertz. This means the amount of cycles that can happen in a given amount of time, in this case, in seconds. For example, if a processor has a 2 GHz clock, it can have up to 2 billion cycles per second. So the higher your clock frequency is, the lower the execution time will be, which for you means a faster processor. The cache. Basically, the cache is the auxiliary memory of a processor where the most accessed data that will be processed is identified and then stored. The processor accesses this memory and is able to execute the action faster because it's more readily available. This is one more important factor that has a direct impact on the processor speed. The more cache there is, the more quick storage capacity you have, which results in a faster speed.
Now, what's cool about this is it's actually a CPU simulator. So in other words, it's a simulator that shows how a standard processor works. The electric signal comes in, and depending on the electrical signal, it's translated into a language of the CPU, such as 0 or 1. Each signal is processed when it's 1. It is not when it is 0. Now, there are different situations in the examples section. For example, I choose the vector. We give the CPU a task. And so in the back, it actually uses language like this. If the CPU sees them, we can say that the processor is running. So let's get running. When we run, on the right side, it stores the data that it receives. On the left side, you see the CPU itself. On the back of what we see as the standard data, there's a simulation like that. At the heart of the CPU is a system on whether it receives an electrical signal and how it processes this electrical signal. So when I want to show the difference, what does 1 byte mean? Well, a 1 byte operation is either 0 or 1. I mean, it takes 2 characters. So when I want to show these 2 characters as 2 different colors, you may think that I could show black or white. Well, if it had been a computer with 1 byte And if I created an image file, it would have 2 colors. So the computer has only a binary order. In other words, if there is a 2-byte computer, it is 2 squared. So I have 4 different situations: 00, 01, 10, and 11. I don't have any other numbers in the binary order. So you can show 4 different colors there. For example, it shows yellow and purple with black and white. In a 4-byte system, this means 2 to the power of 4. So we create a layout that gets 16 different colors. You see where we're going, right? So when we call 32 bytes, this is actually 2 to the 32nd power. You've heard 64 bytes? Well, this is 2 to the 64th power. So the amount of a 32-byte computer system handles 4 billion pieces of data.